This is the first study or the first calculation question for chapter 4, fluid in pipe. Okay, so what we have here is two water tanks, tank 1 and 2, are connected to each other through an 80-meter long, 13 centimeter diameter cast iron. So usually what we do if we see this question is we try to highlight the important part. This is cast iron. Okay, 80-meter long and then 13 centimeter diameter. Right, the water mu, we have the dynamic viscosity and the density flows from tank 1 to tank 2 with a volume flow rate Q is equal to 0.006 meter cube per second. The pipe is also connected with three 90-degree elbows. Okay, K equals to 0.3, a fully open check valve K 0.3. So elbow 1, 2, 3. Okay, and then we have check valve here 1, and then a globe valve here. Okay, the pipe entry here and the pipe exit also contributed in the minor losses in the piping system. Determine the water level difference between tank 1 and tank 2 if both tanks are open to the atmosphere. Okay, so what we are trying to find out is the difference or the height difference between point 1 and point 2. So this will be the elevation. So this is Z1, this should be Z2. Okay, so what should we do first? So as usual, when you find this question, the first step is to find the velocity. So to find the velocity, we use Q and we use diameter. So Q equals to A times V. Okay, so V is equal to Q divided by A. So equal to 0.006 divided by A, I, and then we have 0.13 square over 4. So V should equal to, I think I forgot my calculator. So if can somebody do the calculation for me so that I can compare to my calculation in my handphone, should be good. So I got 0.452 here. So 0.452 meter per second. Okay, so now you find the Reynolds number, Re is equal to rho Vd over mu, so equals to 1000. V is 0.452, D is 0.13, okay, divided by 1.003 times 10 to the power of negative 3. So Re should equal to okay, so I got the answer to be 58,000. 58,000 584, and this is based on this, we can see RE is higher than 4000, so this is turbulent. Okay, so make sure if you do any calculation for RE, you have to state whether this is turbulent or laminar, right? So since this is turbulent, so we have to do the study of Darcy friction factor using Moody Chart. So here, to find out F, we have to use Moody Chart. To prepare ourselves to use Moody Chart, first we need to have the RE to be in terms of here 1, 2, 3, 4. So 5.6 times 10 to the power of 4. Okay, and then the roughness we have to check from the picture. So this is just now cast iron. So cast iron is 0.26 millimeter. So remember, this is millimeter. Please be aware that this is millimeter. So this is 0.26 millimeter. So to find out in meter, you need to divide by 1000.26. Okay, so we will get this to be 0.00026. And then here we need to know the roughness divided by the relative roughness. So 0.00026 divided by 0.13. So you get the answer to be equal to 0.0024 over T. Okay, any question in terms of getting the answer for Moody Chart?
Faham.
Right. Okay, so we will continue for the Moody Chart. Okay, so when we get this RE in this term, E over D is in this term, so you can use the Moody Chart. So the Moody Chart is here, and then what I will do is, first I need to find what is the RE. So RE should be, oh sorry, just now the RE is 5.6, so 10 to the power of 4. First, in the Moody Chart, find 10 to the power of 4, which is here. So anything that we do after this should be on the right side, and the right side should be in 10 to the power of 4. So just now we have 5.6. So if you see here, we have 5, we have 6. So 5.6 should be somewhere here. Okay, in between. Alright, and then use a ruler. Unfortunately, I don't have one right now, so I might use a line here. Okay, so 5.6. Okay, might be here, and then the line will be going up. Oh, sorry. Okay, up to the top, and then I can combine it to be much bigger in size. Okay, so that will be my line. Alright. Okay, so now this is the line 5.6 times 10 to the power of 4. Okay, and then my epsilon over D is 0.02. So relative roughness is 0.02. 0.002, sorry. So 0.002, if you can check from here, 0.002 is practically this pink color line over here. So just follow and up until you meet the intersection. Okay, so here is the intersection. And from the intersection, we will need to draw another line. So we draw another line there. Set line. From here. Okay. So we do a different color. Alright. So we have that to be the answer. So now we have the answer to be, okay, so the first step just now is to find out Reynolds number. So we draw a line and then 0.002 here will be the relative roughness. Okay, and then here will be the Darcy friction factor. So if you can check from here, this is 0.003, this is 0.0025, so 0.025, this is 0.026, 27, 28, 29, 3. Okay, so this is 25, 26, 27. So we can assume this is 26, 2. So can just get the answer to be around, okay, 0.0262. Okay, so make sure you get the reading correctly. Okay, because we have to make sure this is 3, this is 5, 6, 7, 8, 9. So 6, 2. Okay, so 0.0262. What will be the answer for this one? Usually we give it in terms of range, and because 262 is in between 26 and 27, so the range should be 0.0261 up until 0.0269. Okay, so this is very important. So any number below this or higher than this number is considered to be wrong as the Darcy friction factor. Okay. Any question on the Moody chart? Okay.
No, sir.
No. Alright. Okay, so that will be the Moody chart. So we have the answer 0.0262. So here, based on the Moody chart, so we get the answer for the question to be F, 0.0262. So now we can find HL major, which is equal to FL over D V square over 2G, which is equal to F 0.0262. L should be here, 80 meter long given in the question. If not, you have to calculate each one of these pipe length, but it's given. So 80 meter long, diameter is 0.13. Okay, and then V square 0.452 square, and then we have V square 2G, 2 times 9.81. Okay, so that will be question. 262 times 80 divided by 0.13 times 0.452. So the answer is 0.1679. So HL major is equal to 0.1679. Okay, next we do HL minor. So to do HL minor, HL minor, so to do HL minor, so we just use summation of KL. So summation of KL is, number one, we have here given to you 3 90-degree elbow. So 3 times 0.3 plus a fully open check valve. So 1 times 0.3 plus a globe valve 1 times 0.2 plus 5 and 3 1 times 0.5 plus 5 exit 1 times 1.0. So KL should be equal to 2.9. Okay, so we have this as 2.9. So our HL minor should equal to KL, summation of KL, V square over 2G. So 2.9 multiplied by 0.452 square over 2 times 9.81. So HL minor should equal to 0.0302 meter. Okay, right. So HL total should be equal to HL major plus HL minor. So equals to HL major is 0.1679 plus 0.0302. So the answer for HL total is equal to 0.1981 meter. Okay, so you can see if you follow the steps as given to you just now in the first slide, you should be having no problem in answering any questions regarding to any of the major losses or minor losses. Okay, so the last one, determine the water level difference between tank 1 and tank 2 if both tanks are open to the atmosphere. Here again the question, both tanks are open to the atmosphere. Okay, so Z1, Z2 is here. And then we have, because the tank is open to atmosphere, the first thing that you need to know here is, here, P gauge at point 1 should equal to 0. And because this is the surface of a liquid in a tank, velocity at point 1 should also equal to 0. Here, P2 equals to 0 and velocity is also equals to 0. P2 0 because it needs atmosphere, V2 0 because the question over here is based on the surface of the tank or liquid inside the tank. So the velocity is equal to 0. This is gauge pressure equals to 0. So because of that, we can just do a simple calculation or through energy equation. So the energy equation here is P1 over rho g plus Z1 plus V1 square over 2g. We don't have any H pump, so we don't have to add any. But I just put H pump here. Okay, equals to P2 over rho g plus Z2 plus V2 square over 2g plus H turbine plus HL total. Okay, so P1 just now is 0, P2 also 0, V1 also 0, so V2 should also be 0. We don't have any pump, we don't have any turbine. So what we have here is, if we rearrange it again, Z1 minus Z2 is equal to HL total. So it is equal to 0.1981 meter. So that's the answer for this question.